Hey, how are you?
I'm good. Well, how'd you guys do at the casino yesterday?
Well, I actually did really good. I actually made a lot of money within a short amount of time.
Wow, really? How about you, Victor?
For the amount of time I was there, I actually stayed pretty constant. You know, I wasn't winning or losing any money. What about you, Alex?
Well, I did really bad, and when I got home yesterday, I kind of did a little calculation to see how I did. Here, let me show you on the board. So, after our inheritance of $1 million from our interconnected great-great-grandfather, we all had started with $1 million at the casino. But then as I played my hands, I keep losing money, you know, so after playing one hand, I lost a quarter of my $1 million. So I thought if I played another hand, I would gain it back, but no. In my second hand, I lost another $250,000. And so in my third hand, I was left with only the last $250,000. And so my rate of change I'll show you my rate of change actually, because I did some calculation at home. So I used my first point, which was 0 and 1. The 1 is the million that we started with. And then let's pick another point, let's say this point. So let's say 3, hold on, yeah, that's right. My second point would be 0.25. So using the rate of change equation, we can find what my rate of change is. So see, y2, this would be y2, so 0.25 minus y1. This is 1 over x2, this would be x2, 3 minus 0, which might be my x1. And I would get negative 0.75 over 3. And my rate of change would end up to be negative 0.25 million. So I lost that every time I played a hand. It wasn't my lucky day. How about yours, Victor? How does yours look like?
Well, my rate of change is a little bit different. I mean,
yeah. Can you show us? Like, that would be great.
Yeah, I mean, it wasn't as depressing as yours, but...
Yeah, I know. Wasn't a good day for me, you know.
No, not at all. But for me, on the other hand, I only played 4 hands. For each hand, you know, I wasn't winning and I wasn't losing. So I mean, my first hand, I still had $1 million. My second hand, I still had another $1 million. Same with the third and the fourth.
Oh.
So you know, my rate of change was just constant all the way through.
Well, from the graph it looks constant, but can you show me using the equation?
Yeah, so showing your equation, my first point would be 0 and 1. So my initial 0 hands with $1 million, and by the time I left, I played 4 hands and still had $1 million. So using your formula, we would have 1 minus 1 and 4 minus 0. So technically, my rate of change would be 0 over 4 or 0. So by the time I walked out of there, I wasn't winning money and I wasn't losing money.
Oh, I see.
Yeah.
Oh.
So I pretty much stayed the same the whole way through. After 4 hands, I thought that was it, and I was done.
Well, that's good. You get to keep your $1 million.
Yeah.
And I feel bad for you guys because I made my math before you guys, before I came to the casino. So I calculated that if I played every hand, I would make $1 million each hand. So
really?
Yeah.
Huh.
So $1 million one hand, another $1 million, and $3 million. Mathematically, I had started the same like you guys.
Yeah.
And then, doing my rate of change, I got it caused me to have $1 million every single hand.
Huh.
So
what was your trick? How did you make $1 million every time you played?
I calculated the time. I just used my time wisely and played my cards right.
Oh, really? Wow, I should do that next time. I could have saved me so much money and so much time.
Do your math at home. Alright, the rate of change is the speed at which a variable changes over a specific period of time. And Alex will explain how that is on a graph.
So on this graph, you can see that there are 4 points. And in order to find the rate of change, which is this equation here, y2 minus y1 over x2 minus x1, we would pick 2 points to find the rate of change. And so let's say we'll pick these 2 points. So let's say 3, 5, and 1, 1. These will be our 2 points. So since it's rising over increment of time, this would be our first point. And this 3 over 3, 3 into 5, it will be our second point. So we're find the rate of change, y2. This would be y2, because this is x and y, and this is the second one. So y2 minus y, I'll write it bigger. 5 minus y1, okay, so which is 1, over x2, which is 3, minus x1. So we'll have, let's see, 4 over 2. And we can't just stop here because this is a fraction, and so we need to reduce. So 4 divided by 2 equals to 2. So our rate of change would be, well, if we want to write it, we'll write it in a complete sentence. So our rate of change is 2, and that'll be our answer, because it's moving up 2 for every, moving up 2 y-axis, on the y-axis, while moving only 1 on the x-axis. So that will be our rate of change, and that's how you find it.